Yo, 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 Math by the Moon, back with another video today. We're going to look at log and exponential notation. We're also going to look at solving one-to-one logarithmic equations. Doing a little evaluation here in this lesson on Edgenuity as well, evaluation of logs. You're going to want your TI-84 calculator. There's a few of those you'll have to type in. So, you ready? Here we go. So this first notation I have up here should be familiar to you. It's how you can go from an exponential expression or equation into a log equation. And so you have to remember what I would always say is kind of like the backwards C. Base to a power is the answer. This is the typical exponential way that we write exponential equations. If we want to translate it, the true reason for doing logarithms is so that we can find the answer to, hey, these questions of what's the power that I could raise this number to get said answer. Okay, so it's really a way for us to figure out the answer to an exponent question. That's what logs are for. So here we have the base, the answer, and the power is actually what we're trying to solve. So this is where I said that you have to remember like the backwards C method here. So it was base, power, answer. So when I read a log in my mind, what I'm sort of configuring is what's the power that I can raise this base to get this answer, right? Whatever it is. So some easy one right here, like the log base 3 of 9. And when I'm reading this, that's how I said log base 3 of 9 means 3 to what power? Like 3 to the what power over here would give us 9, right? So that's how I sort of think it through. So of course it's 2. A few more examples down here, and you need to be able to go from this log form back to base power answer form, exponential form, pretty proficient. So if I wanted to just rewrite, which they have you do in Edgenuity, if I want to rewrite a log as an exponent problem, I take the base, the power, and the answer, and I transcribe it. 4 to the 5th power equals x plus 2. And now that becomes actually an equation we could solve. You know, you could figure out what 4 to the 5th power would be. So that's 256 times 4. And equal to x plus 2, subtract 2 from both sides, and bang, you got the answer to this this logarithmic equation through rewriting it as an exponent, which is actually going to happen in an upcoming lesson. And we did it in our class already, so it should be familiar. Over here, we did some of these questions in the last unit where we took and rewrote them as one-to-one, but what they really want you to do in this question is just to simply rewrite it as a logarithm. So if we take this, we want to put the base down here, which is a 5, right? We want to put, let me just slide this down a little bit. We want to put right here, we want to be able to put the answer to the question, and the answer is 125 equals our power, which is x plus 2. So again, you just have to be able to remember how to translate base power answer to its original form in exponential form. Okay, so you'll be asked to do a few of those questions on Edgenuity. The other thing you might be asked to do would be some simple evaluations. So you have to be able to process this in your mind, like saying to yourself, well, when I read a log question, what I'm really asking is, in this question, 6 to what power equals 1 over 216. And I picked this one because it's my devil's cube. It's one of my favorite cubes. I mean, I don't really like it, but I always have fun with it because it's 6 times 6 times 6, which is why I call it the devil's cube. And in this case, we need 3 6s to get 216, but we need to throw it to the denominator. So remember how to do that. We need a negative exponent. So this would be -3. And then I chose my Fedi cube, Fedi Wap, 1728, not 38. 1728, this is 12 cubed. 12 to the power of 3 equals 1728. So you see how I'm tracing this out like my backwards C method. Base to this power gives me that 1728. And then for these two questions right here, you got a common log and a natural log. The common log doesn't have a base, but remember that base is always a 10 when it's not down here. So this is saying 10 to what power gives me 128. And I know that that's more than 2, but probably not 3, because 3, 10 to the third would be 1,000. So that's where this comes into play, right here. So I got my log button. Got my log button right here. And I would type 128. Whoops, that's not what I want. Be about 2.11. Use my wavy equal sign. And then this one would be a natural log. A natural log is base E. And remember, E is a number, not a letter in math class. E is a number. It's a constant, 2.71828, blah, 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 1828. It doesn't repeat. It is totally random, but it sounds like them first 7 or 8 digits repeat. The ln of 20, so you're looking at about 3. E is about 3. So ln of 20 should be close to 3, 2.99. 2.995, so we'll call it about 3. Okay, so if it's just something where they ask you to evaluate it by using your graphing calculator, that's fine, you have that. Now, what's it used for? So if we're solving log equations that are one-to-one, you might have a log equation that looks like common log of x minus 3 equals the common log of 17 minus 4x. And I have this lesson here all does one-to-one logs, so you don't have to do any condensing or anything like that. We'll get into that next, which is pretty much your last lesson. So we got log on both sides, which means we can cancel out these logs. And my song was, we condense if we want to, we can leave our logs behind. And if you can't solve a one-to-one log, you ain't no friend of mine. I know. Sorry. It's just that's who I am. Anyway, what we have left is just something simple. X minus 3 equals 17 minus 4x. And hopefully you can solve this one-to-one log, or you ain't no friend of mine. That would be, add that over there would be 5x. Add that over there would be 20. X equaled 4. And it's as simple as that. So when they're one-to-one, cross them bad boys off and solve that one-to-one log. Okay. So if you need any other information on this lesson, I think this lesson is going to go like that for you, because logs were such a thing for us early in the year and throughout the year. Let me know though if you need any help. I'll definitely jump on later.